Hello and welcome to this episode of T-Tech. Today we're going to take a look at the basics of cryptocurrency. So the goal here is just to get you acquainted with some of the essential concepts that kind of interweave through all the different cryptocurrency coins and things of that nature. So here's the first little 101 if you don't know anything about what this is. So essentially, it is a digital store of value. So it's similar. It can be thought of sort of like a digital dollar, but it isn't really quite used like our normal currencies. So it's more of just a store of value at the moment, more like something like an asset, like gold or silver, things like that. But how this operates is in the cryptocurrency, whatever one you use, you have transactions. So these transactions are like when you're sending between wallets of different recipients and other things like that. But these transactions are essentially that wallet to wallet. And two things about them, they are public and they are logged. So where they're logged is on something called a blockchain. That's going to be a very important concept with any cryptocurrency you deal with. It's a blockchain, is what it's called. Now, you can also take the cryptocurrency and you can then exchange it for whatever your government's local fiat currency is. Even you can exchange it for goods and services as well. So there's many uses for it. But back to the actual implementation of it, each crypto coin you use is stored in a digital wallet. So the digital wallet, much like if you still have a wallet in your pocket, things like that, it's a digital version of that. So it stores your money and it keeps track of it. We'll see in a minute how the blockchain ties into how that happens, but it keeps track of the coin you are using. All right. So the wallet's value, though, this is where it really gets interesting. It is not stored in it, at least not directly. The value of the wallet is actually kept track of on the blockchain. So you cannot have a wallet independent of a blockchain. It just doesn't work that way. The blockchain keeps track of every user's wallet of that cryptocurrency, and its job is to keep track of what value each wallet has. And there's other mechanisms that allow the currency to move between wallets. So essentially, when you think wallet, that's what stores your crypto coins. And then that wallet, the value of it is maintained and monitored by the blockchain. All right? Because if we didn't have that, it wouldn't know if you had moved that money, the crypto, to another wallet and things of that nature. But what we're going to talk about now is what is this blockchain? Well, put simply, a blockchain is a ledger essentially. So kind of like in your bank, if you do traditional banking, you can deposit money, you can withdraw money, you can send money to another person that uses the same bank as you, and you can send money across to a different bank. Well, that blockchain keeps track of all that, just like the tellers in the bank would keep track of that. So the whole life of a blockchain essentially is each of the red blocks, labeled 1, 2, 3, and 4 respectively, is describing the crypto moving from one wallet to another wallet. Essentially, they're called inputs to the blockchain, and each input on a block of transactions has a respective output on that transaction, where it's coming from, where it's going to. All right? And as the blockchain progresses, every second of every day this is happening. At least for Bitcoin, at least since 2009. So it's been a long time. But what happens is, as it progresses and transactions use the protocol of the crypto, the blocks get what's called confirmed, or they get validated. So as we move forward, the blocks that are turning green are becoming valid blocks. And that block of transactions is taken care of and things like that. So what does that really mean? Well, it means one, the transaction on that coin's blockchain has successfully moved from, let's say, wallet A to wallet B. But it also means something very important. Everyone that is working to secure the blockchain, which we're going to get to in a second, when those transactions are validated, it's safety for the person that sent it and received it, and the network of the blockchain as a whole, because those funds cannot be used to defraud anyone, or, as they say, double spent on the blockchain. So it's a confirmation. And these blocks of transactions get confirmed over and over and over until there is enough of a consensus that they are successful, not fraudulent, and that they have worked correctly. So, how does that happen? Well, this is the other part, besides the wallet and the blockchain, that makes cryptocurrency work. So this is securing and validating those blockchain transactions. So the blockchain transactions here can be secured in two different methods, and every crypto coin uses their preferred method. You have to remember, a cryptocurrency is only software. So the rules of the software, or the protocol, determine if it's a POW, a proof of work, a consensus mechanism, or a POS, which is a proof of stake consensus mechanism. So proof of work, though, uses an algorithm, like, for instance, with Bitcoin. It uses a cryptographic hash. In this case, it's SHA-256, and that is a mathematical formula that just takes a block of transactions as input, and that calculates a value, and that value has to be recalculated correctly again. And then if you calculate the value correctly in a proof of work blockchain and you submit it back, that proves that that transaction matches up with the value it's supposed to, and that means that block of transactions is legitimate. So it is more complex than that, because different coins have different algorithms that they use. And proof of work, you can think of it's a cryptographic hash. All right, it's actually something similar to a message integrity code, an MIC. So that's what proof of work does. Now, with proof of work, you can use things like ASICs, GPUs, and CPUs to perform that hashing algorithm over and over. And then you can actually get rewarded in that crypto coin's currency, depending on what blockchain you're mining. You could be mining Ethereum. You could be mining something called Ravencoin. You could be mining Bitcoin. That's some proof of work ones. Proof of stake is a little bit, I don't want to say simpler. It's just with proof of work, the main idea of what secures it is called hash rate. The faster you can run those algorithms, the more value you add to that blockchain. So the higher your hash rate, the more transactions per second you'll be able to confirm, and thus the more reward of that coin you will get for confirming those, because it operates the currency. Without proof of work, what's called miners, the currency wouldn't operate. It wouldn't be able to have transactions. It's like a bank without tellers. They wouldn't be able to process transactions either. So proof of stake, though, instead of having CPUs and GPUs and ASICs and hashing power, you have the native currencies that you're using. If you have an Ethereum blockchain, you would stake Ethereum on a validator node. And then the ones that have the most Ethereum are able to do the same process with the math algorithm essentially and secure the blockchain. All right. But it's essentially less memory intensive, but I don't want to deal too much with the implementation. That's already enough of that being described. So proof of work and proof of stake, you can do them either as a solo proof of work. This is much harder to generate successful confirmations because you only have one source of hash rate. And by the way, in proof of work, these are called miners. They just utilize the hardware and are able to mine for that blockchain. With a pooled proof of work, which is what pretty much everyone is doing at this point, the miners pool their resources together to a central server. You send your result that you've calculated on the block to this server. If it's right, that server tells their wallets and things to send a little bit of a reward back to you in a wallet you set up ahead of time. So that's how pooled mining works. You're getting rewarded for securing the blockchain, all right? But you don't have to try to do it yourself. You're finding with a pooled proof of work, you are finding kind of fractions of shares of that block that you solved correctly, all right? With solo, you'd have to solve the entire block, which may not be computationally feasible depending on what hardware you have. So that's the two. Pooled is better, especially nowadays, unless it's a relatively new coin that has very few transactions happening on it. Now, with validators, same thing. You can stake all your ETH, or your Pure Coin is another one that uses proof of stake. Or you can have pooled, where you can have less Ethereum because it is quite a lot to get that much Ethereum to do this. I'm talking about Ethereum because that's the most prominent one at the moment. They're actually moving from proof of work to proof of stake, and that will change the playing field a little bit of how that operates. But there are others for each type of chain. If you just Google proof of work, cryptocurrencies, and then proof of stake, cryptocurrencies, you'll be able to see the differences and everything like that. Same idea though, except it's based off the amount of cryptocurrency you hold or stake to get the right to validate the blocks. So digital wallets. Digital wallets, regardless of the blockchain or how you're securing it, this is how you keep track of how much cryptocurrency you possess. It doesn't matter here. I have 20 BTC. I don't really have that BTC. These are fictional numbers, but this is the amount of BTC you would have. So a software-based one or a hardware one doesn't really matter. They hold values of cryptocurrency. They can be a fraction like 0.1 or 0.05, or they could be, an entire whole one. It doesn't really matter. It just depends on how much you have, things like that. But regardless, if it's software or hardware based, they have a public and private key pair. That's why it's called crypto. It works on cryptography. So the mining has the algorithm hash it's finding, and then what these public and private key pairs do is when a wallet wants to send to another wallet, they exchange public keys. The wallet that wants to send is going to have to use that public key from the receiving wallet to sign the transaction. It's going to sign it just like any other cryptography. It's going to send it out to the wallet, and then the receiving wallet's the only one that's going to be able to receive the funds because they have the private key of that pair. But the difference between a software-based and a hardware-based wallet. A software-based wallet is one that you can install on Windows, on Linux, or on a mobile device. And that wallet hardware, the wallet software rather, will tell the blockchain, how much it has, things of that nature, and then it will be able to maintain that amount. You can receive and transfer, stuff like that. A hardware-based wallet is actually something called an ASIC. So it's essentially an application-specific integrated circuit, but it's a miniature computer that all it does is stores crypto essentially. And it cannot run userland applications like Firefox. It can't open sockets or anything like that. So it's called a cold wallet because there's an actual air gap where it cannot connect to the internet itself. You have to plug it into your machine to interact with it and send and receive funds from it. But they both have public and private key pairs. Hardware is more secure because it's a stripped down version that cannot be compromised as easily as a software based one that might be running just on your desktop. But that's your two types there for hardware wallets. And they store your cryptocurrency. So exchanges are the last thing I want to touch on. Now exchanges, they provide a central place, and with these exchanges, you can sell crypto coins that maybe you get from mining or staking, or maybe you bought them and held them and now the prices went up and you want to sell them for a gain, maybe a loss even if it it's not your day, but you can sell them to your fiat currency if you want. So the crypto blockchain itself is not designed to transfer out of that coin. It's only designed for transactions directly in whatever coin you're using. If it's Bitcoin or Ethereum or whatever, there's no euros going in there. There's no US dollars going in there. That's why you need exchanges, because in exchange for your crypto, they give you your fiat currency. So a lot of them provide an online digital wallet. You can store your crypto there. I only recommend storing it there if you are going to sell it. Otherwise, keep it on a software wallet on your computer, or better yet, buy a hardware wallet. That's highly recommended because that's the most secure way to do it. It does offer security, though, as far as financially against fraud, either fraud done to you or otherwise. But it has KYC, which is know your customer. And, a lot of these exchanges, you do have to be prepared to provide pictures of your identification, picture of yourself, things like that, just so you understand, if you want to use an exchange, how that works and why they have those things in place. But you can also take one cryptocurrency like Ethereum and you can convert it for Bitcoin. They allow you to do that because they take the value of Ethereum. If it was 10 Ethereum, maybe it's worth 20 Bitcoin, just some easy numbers. And they will give you the 20 Bitcoin in exchange for the Ethereum. Just hypothetically, anyway. But that's kind of an overview of a little bit of a few basic things about Bitcoin and other cryptocurrencies, but essentially just a good broad brush overview of crypto. So with that, I do hope it maybe helped you understand a little bit more about this space. It's ever evolving, it changes every day. But I do hope you enjoyed this video, and I'd like to thank you for watching. And as always, it's been Tyler with T-Tech, and have a very nice day.